Hello students, I am here with another video of class 10th from your NCERT book from the chapter Acids, Bases and Salts. Before starting today's video, I would like to tell you all, till now we have discussed about the various properties of acids and bases. We have also studied in detail their chemical nature, as well as we have studied about the acid base indicators, where we have discussed the natural indicators as well as the synthetic indicators. Even I have discussed about the universal way of identifying with the strength of acids and bases, that is pH value. Color code also was being discussed in the last class, and then we were discussing about the salts, its properties, and we have discussed about the salts which are derived from the compound as a compound of sodium chloride. In that we have discussed about the various salts. Now today, in the same sequence, I will discuss about the next salt, that is baking powder. So baking powder produces carbon dioxide on heating, so it is used in making the batter spongy. Okay, so we have heard about this baking powder very much in the bakery shops, or we also, whenever we are required to bake something, we are using this baking powder. Okay, in the last class we have discussed about the baking soda. Now today we will discuss about baking powder. From baking, it is one of the derivative of baking soda. Okay, it is one of the derivative of baking soda. Now how it is being derived, I'll discuss it. Although in baking soda it produces carbon dioxide on heating, but it is used for cooking because on heating baking soda produces sodium carbonate along with the carbon dioxide. So what is the chemical formula for this baking powder? The chemical formula for this baking powder is sodium hydrogen carbonate. Okay, it is the sodium carbonate. Then it is also used very much, therefore it is also used very much in the baking process. Okay, so this baking soda is different from baking powder, as baking soda is sodium hydrogen carbonate, whereas baking powder is the anhydrous form. Okay, it is being heated up. Now how it is being formed, as the sodium carbonate produces the taste and it makes the taste bitter. Okay, now this baking soda, how it is being formed, it is written here in the form of reactions, where NaHCO3 means sodium hydrogen carbonate or baking soda is going to be heated to form sodium carbonate, water and carbon dioxide. So baking powder is a mixture of baking soda and mild edible acid. Generally, tartaric acid is mixed with baking soda for making baking powder. Okay, so tartaric acid is one of the substitute which is being added, which is one of the reactant which is added with sodium hydrogen carbonate, that is baking soda, and then it is going to form baking powder. How it is being formed, see here it's written baking soda, and then we are going to add tartaric acid. The formula for tartaric acid is C4H6O6. Then it is going to produce carbon dioxide and water and sodium tartarate, Na2C4H4O6. When baking powder is heated, to sodium hydrogen carbonate decomposes to form carbon dioxide and sodium carbonate. So this carbon dioxide is released, and whenever it is released in the dough, it is going to be released in the form of bubbles, and from the dough, from where it is released in the form of bubbles, it is going to leave the space and a network is going to be formed. It is going to make the bread spongy. Okay, so it is going to make the bread spongy. So whenever this carbon dioxide is released, it is leaving the batter in the form of fluffy, or it makes the cake fluffy. So tartaric acid helps to remove the bitter taste in the formation of Na2CO3. So this Na2CO3 is the chemical name for baking powder, which is formed because of the reaction with tartaric acid and baking soda. Now if only baking soda is used to form baking powder, then what will happen? If we are going to simply heat it, it is going to form baking powder, but the bitter taste of baking soda also be present. So for removing the bitter taste of this baking soda, this tartaric acid is being used. So it helps in the removal of bitterness from the baking soda. Okay, now next we have to discuss is about the washing soda, that is known as sodium carbonate. This sodium carbonate is manufactured by thermal decomposition of sodium hydrogen carbonate, and which is obtained by Solvay process. So this is obtained by the process called Solvay process. In this, sodium chloride is added with carbon dioxide, with ammonia and water to form ammonium chloride and sodium bicarbonate, NaHCO3. Now after this, NaHCO3 is going to be heated and it is going to form sodium carbonate, which is anhydrous form. This sodium carbonate is known as washing soda. So this sodium hydrogen carbonate is obtained in this process, okay, which is dry in nature. It is also called soda ash. Okay, so this is sodium carbonate and it is obtained after the heating of sodium bicarbonate, which releases carbon dioxide, water, and it makes sodium carbonate, which is in anhydrous form. So anhydrous form is also known as soda ash. I'll just tell you about anhydrous and hydrated forms of the salt in the further class. In the furthest line in this class only, I'll discuss about the same thing. The next is washing soda is obtained by rehydration of anhydrous sodium carbonate. Now how is this sodium carbonate formed? Sodium carbonate is normally known as the baking soda, but when it is hydrated, then it is known as sodium hydrogen. This is hydrated and it is known as sodium carbonate, and which is known as washing soda. Okay, so NaCO3 plus 10H2O. This H2O water is going to be added to form the crystals of sodium carbonate, that is hydrated form. Okay, now this is going to form the water of crystallization. This is because of water of crystallization. In the further slide, I'll discuss about what is water of crystallization. Hence now it is the number of water molecules. Now here 10 water molecules are always required for making this washing soda. It is also known as, therefore the name becomes sodium bicarbonate decahydrate. Why decahydrate? 10 hydrogen water molecule is added to it, so this becomes sodium bicarbonate decahydrate. Sodium carbonate is a crystalline solid which is soluble in water when most of the whereas most of the carbonates are insoluble in water. Okay, so this is one of the soluble form of carbonate, as it is. Why it is an exceptional? Because most of the carbonates are insoluble in water. Next is sodium carbonate. What is the use of sodium carbonate? Sodium carbonate is also known as soda ash, I told you. So it is used for, as the name suggests, it is washing soda, means it is always used for washing the clothes, especially in rural areas. Okay, so this is known as washing soda. It is also used for washing. It is very clear from the name itself. Next thing is that it is used for making detergent, cakes and powder. In the industries, it is used for making detergent, cakes and powder. Now on removing, it also helps in removal of the hardness of water. It is going to remove the hardness permanently. And then it is used in glass and paper industries. Fine, so there are various uses of this sodium carbonate in many fields, such as for washing clothes. It is used for making the washing powders. Then it is also helps in the removal of the hardness of water, and it permanently removes. Okay, it is not going to remove temporarily, it is going to remove permanently the hardness of water. Now it is going to be used in the glass as well as in the paper industries. Next thing is the new topic, that is what. So that was all about the salts and the different types of salts which are obtained from the as a compounder sodium chloride, as sodium chloride is one of the most important, one of the most common form of the salt which is used. Now the uses of various salts we have seen. Now after crystallization, water crystallization, I'll just tell you about one of the salt which is left out after reading this water crystallization. Okay, now next is the water of crystallization. Now what is the meaning of the word crystallization? Or first tell me the meaning of the word crystal. So what is the meaning of this word crystal, and Is it solid, liquid, or gas? Firstly, I will tell you that these crystals are solid in nature. Okay, so these are solid in nature, and they are the special types of solid. Why they are the special types of solid? Because they are forming a special shape. They are in special shape. Now, crystals are the solids which forms the special shape, which are formed in the special shape. Why? Now, I'm talking about the special shape? Because they have the uniformity in their shape. For example, crystals of your sugar and or the salt crystals. So why crystal? Crystal is having the name. This salt is having the name of crystal because it has a particular shape. It is cube in nature. Okay, now why these are cube in nature? It's not necessary that all the crystals are cubical in nature. There could be many other forms of, there could be many other shapes of crystals. And so here we will discuss about why is this crystal being formed. So this crystal is being formed because of this property of water of crystallization. Now what is this water of crystallization? Water means it is a water crystallization means it is some kind of water which is related with crystallization. Now crystallization means the formation or the way of the process of forming crystals. Now how is this crystal formed? Crystal is formed because of the water of crystallization. Now many salt contain water of crystallization, which is known as hydrated salt. Fine. So what before that I would just like to tell you about the definition of this water of crystallization. Water of crystallization is the fixed number of water molecules which is present in one formula unit of a salt. Okay, for making one molecule, please remember, for making one molecule of crystal of any salt, the number of water molecule which is required, okay, the number of water molecule which is required to make one molecule of crystal of salt, that is known as water of crystallization. Okay, how much water is required for making one molecule of crystal? The same amount is known as, same number is known as water of crystallization. So what the definition becomes, the water molecule which is present in the salt crystal is known as water of crystallization. Okay, the number of water molecule which is required to make one crystal of the salt is known as water of crystallization. Now here one example, one very common example which is given in your NCERT book is, I have quoted here also, that is the crystal of copper sulfate. Now crystal of copper, the formula for crystal of copper sulfate is CuSO4 0.5H2O. Now why after decimal you have written 5H2O? 5H2O means for making this one molecule of copper sulfate, we require how many molecules of water? We require 5 molecules of water. Okay, so please remember that after decimal, after point, we are writing the numbers, and that will be known as water crystallization. Okay, just before only I have taught you about this sodium carbonate, which is hydrated form. Now why this hydrated form? Because it contains 10 molecule of water. After decimal we have written 10H2O. Now this Na2CO3 is hydrated because it is formed in the form of crystals. Why it is formed of crystals? Because it has water of crystallization in it, and this water of crystallization is represented just after the formula of the salt. So here how much water of crystallization is required? It requires 10 molecules of water crystallization for forming one molecule of this sodium carbonate. Similarly, here in this copper sulfate, why pentahydrate? So it is called pentahydrate because it contains 5 molecules of water crystallization. Now here why it is called decahydrate? Because it contains 10 molecule of water of crystallization. Okay, so the number of molecules of water which is required for making one formula unit of any crystal is known as water of crystallization, and it varies from one crystal to one form of salt to another form. Now how is this made? This is one of the activity which is given in your NCERT book, where you are going to make the saturated solution of this copper sulfate salt, and then we are going to heat it for some time, and then we are going to leave it for overnight, and then the next day the crystals will be we will see that in the china dish the crystals will be formed. Now I'll read out the way by which this water crystallization, this was also present in the 7th class also, if you remember. So this water crystallization is very common for forming the various shapes in the crystals, or the various shapes of the crystal is due to this water crystallization. Okay, so this water crystallization helps in maintaining the shape of the crystals of salt. Okay, fine. Now this water of crystallization, here five molecules of water of crystallization which is present is that is why it is known as pentahydrate. And in the last I have told you about it, in the last this was about the form of 10 molecules were there. It means it was decahydrate. Now this and crystal and the main thing is that water is present. We are writing this water here, that as 5H2O, but where is that water present? Is that water going to be moisten this salt? No, we are not able to find any kind of moisture in this salt of sodium copper sulfate pentahydrate. If we are going to see these crystals, they are dry enough. So okay, so it is dry enough. Why it is dry enough? Since it is having water of crystallization in its formula, but still we are not able to see any kind of moisture. Why? Because these are trapped in between the crystals of this copper sulfate. Okay, so it helps in maintaining the shape of the copper sulfate, so it is not going to moisten the hands. The copper sulfate is whenever the salt which contains water of crystallization in them. Okay, those salts which has water of crystallization in them, so they are known as the and they are known as hydrated salt. Okay, hydrated means they are having water in it. Okay, so they are called hydrated salt. Please remember these two words, hydrated. And then now how this hydrated salt is going to be free of this water crystallization? Simply by heating. And after heating this hydrated salt is going to be turned into anhydrous salt. Okay, this anhydrous salt is known as the salt from which you have removed the water of crystallization. Okay, this hydrated salt becomes a dry salt. Means wet salt is known as, or which contains water of crystallization, is known as the they are called hydrated salt. And those crystals which are free of this water of crystallization, they are known as the anhydrous crystals. Okay, anhydrous salts. So please remember, this is it turns whenever this blue copper sulfate crystals are being heated, they are going to convert in the white colored crystals. They are known as anhydrous copper sulfate. Now after adding water to it, anhydrous copper sulfate again becomes blue. So this is the reaction for formation of hydrated salt and anhydrous salt. So hydrated salt is formed after the reaction of this hydrated salt with heat. Okay, so we are going to simply heat this copper sulfate crystals. It is going to lose water of crystallization. It is known as CuSO4, means this is known as anhydrous copper sulfate. Okay, now you can see the difference between the color of these two salts. So the color and the shape is maintained because of this water crystallization. So hydrated sulfate of copper, or this copper 2 sulfate pentahydrate CuSO4.5H2 is blue in color. So these are the crystals of copper sulfate which you could see here. Now after that, what you are going to do, when you are going to heat this, once this hydrated form of copper sulfate is heated up, it is going to form the crystals. It is going to change the color and it is going to be white in color. So this white colored salt is known as anhydrous copper 2 sulfate. The formula remains same, only the water crystallization is released. So once it is released, it becomes dry and it is known as anhydrous. The word hydrated means, this hydrated means hydro means water. So this hydrated here means the salt which has water of crystallization in it. But remember that it is not a wet salt. It is just the water of crystallization which is maintaining the shape, and it is present in each and every crystal of the copper sulfate. So for making one crystal, 5 molecule of water. It is surrounded by 5 molecule of water. Okay. So this was about water crystallization. Now these are the various hydrated crystals we can see from left to right. That is cobalt nitrate. This is cobalt nitrate, which contains water crystallization. And see, you can see that these are various colored salts. Okay, so calcium nitrate is there, nickel sulfate is there. Then next is the manganese sulfate, this one, copper sulfate, and chromium potassium. This is chromium potassium sulfate at the bottom. So these are the different shapes and different colors of the salts which you could see here, and these are all about the hydrated forms of the salt. Okay, now next thing is that what is the meaning of hydrated and anhydrous salt. So I have told you that hydrated salts means the salts which contains water crystallization, and which means that, see, it's written here, which is given in your book also, which we have discussed already. CuSO 4.5H2O and Na2CO3.10H2O. Fine. Now anhydrous salt means salt without water crystallization, that is known as anhydrous salt. It is very simple to obtain the anhydrous salt from the hydrated one. Why it is very easy? Because we are going to simply heat the hydrated salt, from where it is going to be converted into anhydrous forms. Now I will tell you about the various examples of hydrated crystals of the salts. Now here is cobalt chloride hexahydrate, means 6H2O. Okay, so why hexahydrate? Because it contains 6H2O, means 6 water molecules are required for making 1 molecule of cobalt chloride. Next is copper sulfate pentahydrate. This we have discussed in detail, where you will make, I told you how to make this copper sulfate crystals. It's very easy. I told you that we are going to form the copper sulfate, and we are going to take water in the copper sulfate. Then we are going to make saturated solution. Saturated solution means the solution in which no more salt is to be dissolved. Now then after that we are going to heat it little bit, and then we are again going to add some more copper sulfate to make it supersaturated solution. Now supersaturated solution is made after the saturated solution. Once the supersaturated solution is being obtained, it is kept in that china dish for overnight. After keeping this overnight, we are going to find that in the next morning we are going to see the crystals which are present in the china dish. Okay, so we can make the hydrated forms of the salt in this way, or we can make the crystals. Okay, so we can obtain the crystal from there. Once the crystals are being obtained, you can simply heat it and form as anhydrous salts. Fine. Now next is the iron sulfate heptahydrate. Why heptahydrate? Because 7 water molecules are required. So ferrous sulfate is there, or iron sulfate is there, FeSO 4.7H2O. So the name of the water crystallization is written as monohydrate, dihydrate, trihydrate, and then if 5 are there, then pentahydrate. 6 are there, then hexahydrate. 7 molecule of water crystallization is there, then we are writing heptahydrate. Okay, so iron sulfate is having 7 molecules of water of crystallization, that is why it is known as heptahydrate. Next is magnesium sulfate heptahydrate. Again here in this also MgSO 4.7H2O is there. So 7H2O means they are having 7 molecule of water crystallization, means 7 molecules are required to form 1 molecule of MgSO4. Okay, MgSO4. Next is sodium carbonate decahydrate. Sodium carbonate means Na2CO3.10H2. Why decahydrate? Deca means 10. So this decahydrate here, this crystal, 10 molecule of water crystallization is required for forming 1 molecule of Na2CO3. Okay, Na2CO3. So here also it's written Na2CO3.10H2O. So this 10H2O represents a water of crystallization which is required to maintain the shape of any chemical, which is required to maintain the shape of any crystal of the salt. Next is sodium hydrogen carbonate monohydrate. Sodium hydrogen sulfate monohydrate. This is NaHSO4.H2O. Monohydrate means only 1 molecule of water is required for making 1 crystal of sodium hydrogen sulfate. Next is sodium sulfate decahydrate, that is Na2SO4.10H2O, where sodium sulfate is there and we require only 10 water molecule to form 1 sodium sulfate. Okay, so 1 molecule of sodium sulfate requires 10 molecules of water crystallization. So in this table it's very clear that from crystal to crystal, from salt to salt, if we are making hydrated crystals, then the number of water molecules also changes, and if the number of water molecule is going to change, it is going to change the shape of the salt crystals. Okay, so these were about the hydrated salts. Next salt which is left is the plaster of Paris, where half molecule of water is required for maintaining one crystal of this plaster of Paris, that is calcium sulfate. Now what is this? Chemically, this plaster of Paris is the calcium sulfate hemihydrate, means only half water molecule is required. Why it is called plaster of Paris? Because it was obtained from gypsum, and gypsum is mainly found in Paris. So that is why it is known as plaster of Paris. Okay, so this is about the plaster of Paris, and it is chemically known as the calcium sulfate hemihydrate. Please remember the name, calcium sulfate hemihydrate. Okay, so it was found, first time it was found in the Paris. Fine. So this is the picture of the plaster of Paris, which is in the powdered form mainly. Next we will see about the preparation of this plaster of Paris. Plaster of Paris is obtained by heating gypsum. So the formula for gypsum is CuSO4.2H2O, which is heated at 373 Kelvin to form CuSO4.2H2O, and 3/2 H2O is released. Okay, so whatever is left is half H2O, which makes one crystal of plaster of Paris, that is CuSO4. Okay, now next is that we will just heat this gypsum. So half of the water crystallization is added to this CuSO4, it becomes plaster of Paris. Next is, what is the property of what plaster of Paris? As you could see that it is a white powder. It is mixed with water to form crystals. Okay, so it can set into hard mass. So this is one of the best property for the plaster of Paris. It is going to set into hard mass. So when we are going to add this water crystallization, it is again whenever we are adding water from outside, means 3/2 water molecule is required to again convert this half H2O into CuSO4 plus 2H2O. That is why it becomes gypsum. CuSO4.2H2O, so it becomes gypsum again. So after setting down, it becomes gypsum. So this is known as this is the quality of what this plaster of Paris, so that it could be set up into a hard mass. That is why we could make many articles by using the same formula, by using the same method for after making a paste of this plaster of Paris. We cannot leave that paste for much longer time, as it is going to dry very quickly. So this setting is an exothermic process, means heat is evolved. After this heat, the setting process may be crystallized by sodium chloride, and it is retarded by borax or alum. If we add alum to this solution, so we can to this paste, so we can retard the sodium chloride by using this borax and alum. Okay. The next thing is that whenever plaster of Paris is heated to 473, it forms anhydrous calcium sulfate, means water of crystallization will be released. So whatever is left will be anhydrous calcium sulfate, that is CuSO4 only. It is not going to have 2H2O in it, but before it was having 2H2O in the combined form, so it forms gypsum, it sets into gypsum. But once we are adding water to it, it is going to form and when we are going to heat it to 473 Kelvin, okay, so it is going to form CuSO4 only. It means it is the anhydrous form of calcium sulfate, which does not contain any water crystallization. It has but it has not having the setting property, as it takes a water very slowly. Okay, so it is not going to be set up into a hard mass. That is why we cannot use this gypsum. We cannot use this anhydrous form. Only we can use the hydrated form of gypsum, that is CuSO4.2H2O, to form plaster of Paris after heating. Next is, what are the uses of plaster of Paris? It is one of the most common use of this plaster of Paris is in maintaining the fractured bone. In dislocated bones also sets into right place. So I will show you the picture of the use of this plaster of Paris. That is, it is used in maintaining the fractured bones. It is used for healing up the fractured bones. So it is used in plaster, in making plaster. Next thing is that it is used to make decorative toys or it is used to make toys or decorative materials. So you could see here it is used for making decorative materials. Okay, now next use of this plaster of Paris is for making the statues, for making toys and surgical instruments. Okay, it is also used in making the blackboard chalks. Okay, fine. Now next thing is that it is used in dentistry. What is this dentistry? Dentistry means it is used in making the molds of teeth, and sometimes whenever filling has to be done, in that filling also sometimes somewhere a small amount of plaster of Paris is only used in filling these gaps. So it is used for making molds of the teeth, so that the teeth could be molded very properly. Next is that it is used for making the wall smooth. So whenever before painting also, sometimes what people do now, after the plaster off from the cement, the houses are being they are being smoothed. I mean, the walls of the houses are being smoothed with the help of plaster of Paris nowadays, so that the finishing of the paint would come in a very fine manner. So it is also used in laboratories for sealing air gaps and in the apparatus to make it all right. So these are the various uses of plaster of Paris, and these are the pictures which is going to show you the various uses of this plaster of Paris. Okay, so these are the use of this POPs. It is in the short, it is known as POP. Now I have told you much about these salts, and we have discussed about the acids, bases and salts now. So I would just revise the things what we have learned till now. Means this chapter, acid, base and salts. Acid base indicators are the dyes, or is the mixture of dyes which is used to indicate the presence of acids and bases. Okay, the acidic nature of the substance is due to the formation of H plus ions, and formation of OH minus ions also is responsible for the basic nature of the substance. Next thing is that whenever an acid is going to react with metal, hydrogen gas is released. Similarly, base also reacts with metals. Okay, so we have also read about the chemical properties of the acids and bases. Then next is whenever acids reacts with metal carbonate, metal hydrogen carbonate, it gives rise to carbon dioxide gas and water. And please remember the tests of hydrogen as well as the carbon dioxide. So for hydrogen, pop sound test is very much required, and for finding out carbon dioxide, we are using the lime water test. Now next we have studied about the pH, where neutral substance has pH of 7, acidic substance has the pH less than 7, and basic substance has the pH more than 7. Now living beings, they also carried out metabolic activities at optimal pH, where blood has a definite pH, saliva has definite pH, and stomach has definite pH for the metabolic activities. Okay, next we have studied about the mixing of concentrated acid and bases into water is very exothermic process, is highly exothermic process, so it is to be done with care. Fine. Salts, their acids and bases neutralize each other to form salt and water. This is known as the neutralization reaction. Then water crystallization is the fixed number of water molecules which is required for making the crystals. And lastly, we have studied about the crystals and the salts which are used in our everyday life and in the industries. So children, that's all was there. That's all is present in this lesson which we have discussed till now. So that's all for today. I'll meet you all in the next video with the next chapter, as this chapter is over. Now I would request you all to complete the question answers of this chapter in your notebook. So that's all for today. I'll meet you all in the next video with the next chapter to be discussed. Thank you for watching the video.